Hi, my name is Paul Fredrickson. I'm a junior studying computer engineering at Purdue University. Last summer, I started an NSF-funded undergraduate research project to make the Darwin-OP Humanoid robot play the video game Dance Dance Revolution. This project combines image processing with robotic movement. First, I'll show a working version of the project, and then I'll explain a little bit about the program. The program that I use has arrows which come 3 seconds apart. This is a different angle of the same program being run. You'll notice that in the bottom right-hand corner of your screen, you'll see a series of images. These images are the pictures which Darwin takes with his camera. For cosmetic purposes, any arrow which Darwin recognizes as being an arrow is colored red. This is the dance pad that I made specifically for Darwin. It has an up, down, left, and right button that connects to a microcontroller, which connects to a computer via a USB cable. If you'd like more information on the dance pad, please see my previous video. However, I would like to take some time to talk about the bar. Originally, I had not wanted to use a bar, and I could accomplish a step one of two ways. The first way, say if I was making a right step, would be to shift all of my weight onto the left leg, move my right leg out, collapse on the left leg, and then bring it back up into the neutral position. However, this put a lot of strain on that left leg, and it took a little bit longer than I wanted. The other way would be to shift all of the weight onto the right button, and then shift all of the weight back to the middle. However, this also took longer than I wanted. Both of these methods changed the position of Darwin's camera, thus changing his point of reference. So I added the bar to increase stability and to provide a fixed point of reference. I justify this by saying that many DDR dance pads, high-end ones, have a bar in the back for humans to use, so Darwin has a bar in the front for him to use. I would now like to talk about the image processing aspect of this project. I use a few libraries in OpenCV to accomplish much of the image processing. Specifically, I use CV blobs to find the arrows. When the program starts, Darwin runs a function in CV blobs that finds blobs of a certain pixel range. We will find 4 blobs, and these are the 4 base arrows. They act as a reference point for the falling arrows. When the arrows start to fall, he will continually take pictures. And when he finds an arrow that is not a base arrow, he will figure out what type of arrow it is in, by what column it is in. He will then store the y-coordinate and the time of 2 successive pictures, and then uses those values to compute the velocity of the arrow. Once he has the velocity, he can find the estimated time it will cross the base arrow. He then sends this information to a thread, which will execute the step at the estimated time. However, this method is not perfect. His head does subtly move when executing a step, and this slight movement can cause some inaccuracy with the estimated time. The time between the arrows in the program that I showed earlier was 3 seconds. For a human, 3 seconds is pretty slow. Darwin is limited by the speed of his motors as well as the computational power of his processor. The execution time of a step is between 1 and 1.2 seconds, so Darwin is more limited by the computational power of his processor. This program can be changed to shorten the steps, but I've noticed that the inaccuracies of the steps become more noticeable as the time between the steps decreases. My program could be optimized so that Darwin could step faster, but it would be pretty challenging to make Darwin step faster than 2 seconds per step. I would like to thank Professor Liu, Professor Lee, Professor Ko for their help and support on this project. I would also like to thank the grad students in the lab, Andy Park, Rami Azrai, and Roy Chang for their help. Lastly, I'd like to thank the National Science Foundation, since I was funded as an RU student. It will probably be a while before robots will be able to beat humans in Dance Dance Revolution, but improvements in hardware will increase the processing power and the motor speeds of humanoid robots. Thanks for watching.